The global situation seems dark right now, with the globe facing a pandemic and a climate crisis. How do we transition to a brighter future where subsurface energy no longer means carbon emissions? How do we transition existing wells to clean, distributed baseload electrical power generation? Welcome to Transitional Energy. The climate crisis is reaching a boiling point and is not going away so long as humans continue to burn carbon fuels. Ever hotter summers, warmer and more moist winters, and more unpredictable weather await unless there is a way to decarbonize our baseload power. Yet we all want appliances that make our lives easier. Cooked food and heating and cooling, urban transportation, electric cars, entertainment, and education, all reliant on energy. In an increasingly electrified world, we've got places to go. Yet, how will we get there cleanly? Transitional Energy seeks to reuse and recycle spent wells where heat and fluid flow rates are adequate to generate electricity. We'll do this directly for large clients behind the meter and for the grid. A quick time to market, 1.5 years compared to 7 years, lowers overall costs and removes the costly process steps of geothermal exploration and drilling. How does open-loop geothermal work? We start with 2 wells, a production well and an injection well that both intersect the same porous and permeable rock. The wells are about 1/2 mile to 1 mile apart. Porous and permeable means there isn't any lake down there. Instead, there's a myriad of little spaces and pathways storing water, keeping it hot with heat from the center of the earth. We pump water up our production well and into our heat power unit that generates the electricity. Once we've generated all the electricity we can and use the water potentially for other purposes like heating buildings and removing minerals like salts and trace metals for batteries, we flow the water over to our injection well, where it re-enters the earth a little bit cooler than it was when we pumped it up. The water returns to a myriad of pathways and spaces that reheat it back to the original temperature it was. These water-bearing rock zones are sheets of rock that can be over 100 feet thick and cover hundreds to thousands of square miles. There's plenty of hot water down there. The heat power units themselves work like an air conditioner in reverse through a process called the organic Rankine cycle. Hot fluid from our well enters and exits the unit, heating up an internal closed loop, which generates electricity before it's cooled and returns to the hot side. These are off-the-shelf units that are made by a variety of manufacturers around the world. Most are about the size of a small shipping container. These units are in use all over the world in geothermal applications. They are literally everywhere. How do we know where to look for these underground geothermal areas? We use science and engineering paired with lots and lots of data and our team experience to find the optimal locations. We've pored over this data for the past 2 years, and we are ready to deploy. Who are we? We're a team of 4 energy professionals ready to transition and decarbonize subsurface energy and geothermal. We've got 71 years combined experience. We've got a talented group of technical advisors with geothermal, oil and gas, environmental, and entrepreneurial experience. We're looking for investors. Will you help us transition subsurface energy to a green energy future? We're bridging the energy gap. Find out more at transitionalenergy.us and reach us at info@trenisol.com.